Welcome to the guide video for the Ortet Mark One MIDI controller kit. Today we're going to talk about turning this into this, and then this. This is an advanced entry-level kit, because although it is not particularly complicated, it does require surface mount assembly, and we will be reflowing solder. So I'm going to assume that you have some basic experience with soldering and electronics assembly, but not that you've done surface mount or reflow work before, and we'll talk about those processes as we come to them. So hopefully this is accessible to anyone who's done some electronics, and if you want an introduction to surface mount work, this might be a good place to start. Let's talk about what you'll need. First, you'll need this kit. You can buy this from me, there's a link in the description, or if you're comfortable gathering components yourself, the designs for the hardware and the software are both open source, and so you're free to assemble the components from whatever sources you want and do that part yourself. So if you have the kit, then you'll need a few tools. You'll need some reasonable wire cutters, some needle nose pliers, a pair of tweezers that are reasonably fine, a knife. It'll be nice to have some wire strippers, some solder, wire solder, and just a regular soldering iron. And you will also need some paste solder. So you can order this from any number of places. I'll put a link to where I bought this particular tube. Any solder paste should work for this, but this one does definitely work. And then something to spread the solder paste with, since we won't be using a stencil for this. We'll be spreading the paste by hand. You'll need a toothpick or a bamboo skewer. Okay. Beyond that, there's not much else you need. You may want some sandpaper, that's useful. Maybe even a file. Those are optional. And then the one big piece you'll need that's not here is you will need something to use for the reflow, which will be a used frying pan, probably. And I'll talk about that when we get to reflowing later in the video. So, set the tools aside, what's in the kit? All right, so we have a number of things. We have a Raspberry Pi, and this is the logic of the controller. If you buy the kit from me, this will come pre-programmed with the firmware for this particular MIDI controller. And if you buy it yourself, then you'll have to flash the firmware on your own. There's instructions on how to do that on the repo for the firmware. We have some ribbon cable, some potentiometers. Now, depending on how many potentiometers you ordered with the kit or choose to buy, you'll have as many as 8. For this example, I have 3. If you get the kit from me, there'll be a rough oak knob for each potentiometer. And if you don't buy it from me, then you'll have to come up with some sort of knob yourself. There's a PCB. Some pieces of wire, 2 insulated and 1 raw copper wire, and some hardware for making the plugs on the ribbon cable. So there's a female side and a male side. Some capacitors. These are quite small, and so I'll give you some extras in case you happen to lose some, because that's easy enough to do. And then there is a little package with some slightly more delicate stuff in it. And so in that, there's a dip switch. This is used for setting parameters on the board, and an 8-channel analog to digital converter. This will connect the potentiometers to the microcontroller. So this is actually the heart of the device. And that's it. That's our kit. So to start with, we're going to set the stuff for the knobs and the potentiometers, the ribbon cable, the wiring, and the male part of the cable connector aside, and we're going to focus on the rest of this for now, along with the microcontroller. So the PCB that you get may have some little nubbins on it, and you'll want to cut those off. And then that leaves some rough parts. If you want, you can take a file and smooth those down. I like to do that just so there's not any rough surface. That is totally optional, and any file will be able to do that. Okay, get the dust off. Now we're ready to go. All right. So this board is two-sided. There's this side, which is the more complicated part that has all of the custom bits for this controller. And then this side is just for mounting the Raspberry Pi. So we're going to do most of the work on this side. This is the harder part. And it's not actually that hard, but it's the hardest part. So what we're going to do is we're going to put solder paste on all of these pads, mount the components to the solder paste. Then we're going to move over to the kitchen and reflow, which is done with, well, there's a bunch of different ways of doing it. I'm going to do it with a frying pan, which is a sort of standard DIY technique. And that's going to be, we're going to, once we've got the paste down and all the components laid out on the board, and they stick to the paste a little bit so they don't move around, we're going to heat the whole thing very carefully, and that will melt the solder and stick the components down permanently. And then we'll come back and we will mount the Raspberry Pi just by soldering individual pads with a soldering iron. To start with, I'm going to zoom you in a little bit. We're just going to put some solder down. Now, we want solder on every pad, and we're gonna use all of these pads, and I'm going to talk about this section here in a second because that's a little more complicated. Everything else just gets the component on top of it. Here we're going to have to make some decisions that will depend on what exactly you want to do. This doesn't have to be super precious. If you smear the solder around a little bit, it's not the end of the world, but you do want to get it as close to the pads as possible, and you don't want huge globs. It's the surface tension of the melted solder will suck it right down onto the pads, and so it sort of arranges itself. But you do need, you know, not too much, and you can't have any pad that's just doesn't have any solder at all, because then it won't stick to the component. But it's relatively forgiving. It's worth making sure that you've got plenty of solder on the pads for this largest one in the center, which is the pad for this part that the ribbon cable plugs into, because this actually has some mechanical stress on it when you plug and unplug the ribbon cable, and so you want to make extra sure that there's plenty of solder holding it down. Okay, so now we're done with that. So I'm going to move on to the next most fiddly part, which is putting the capacitors down. So that you're going to get 2 bits of capacitors, and I've given you a couple of extra of each because they're so small that they're relatively easy to lose. So we're going to start with the 0.1 microfarad capacitor, and this is a little power filter, and it's going to go in this pad here. So this is away from the big stuff, this little one at this end. And these little strips have a plastic cover on them that you pull off, and then I usually just tap the capacitor out onto the work surface and try not to lose it, because there you can see it's sticking to these tweezers because they're magnetized. It's this you can get the camera to focus on it. This little teeny, like smaller than a grain of rice, And what we're going to do is we're going to very carefully set it down into the sticky solder paste on the pad where it needs to go. And the solder will hold it there. So now as long as we don't bump it or fiddle with it anymore, it's stuck and it's good. And then we're going to do the other capacitors. And these we have more of. So this is the point at which you need to make some decisions about what you're doing. I have 3 potentiometers, which means I'm going to have 3 knobs, which means I'm using 3 channels on the analog to digital converter. And each of these little pads here in this section, the C1, C2, C3, C4, these represent a channel. And for the channels that you are using, you want a capacitor on these pads. For the channels that you're not using, you want the pads shorted together. And that's just to control noise. So I'm using 3 channels. This supports up to 8 channels. I'm only going to use 3 this time, which means I'm going to put 3 of these capacitors down on the first 3 sets of pads, so C1, C2, and C3. And I'm going to short the rest of them together. And I'll do that part after we've reflowed. But right now I need to get these capacitors down. So I'm going to open this up by peeling this plastic back, which is a little bit tricky to do. There we go. And I need 3 of these and try and leave the rest of them covered. Okay, so there. Now I have 3 of these little teeny capacitors. I'm going to grab them one at a time. And these are unpolarized, so it doesn't actually matter what orientation you put them in. You just want them across the 2 pads. That's all that matters. And this would be easier if it was not using magnetized tweezers. Okay. And now, so these don't have to be stuck down perfectly. Again, the surface tension of the solder actually puts quite a lot of force on these when it melts, and it will sort of pull them into a better orientation. So as long as they're straddling the pad you want them attached to, that's really all that matters at this point. And just make sure they're good and stuck down. Okay, great. So you can hardly see that in the camera. But there, we have 3 capacitors down. The rest of the pads I'm just gonna leave open like that, and they'll get tinned by the solder, and then I'll come back and short them later. So that's it. That's the hardest part of this build done. And the rest of this is pretty straightforward. We're just gonna put the other big components on. So let's start with the dip switch. Now this goes with the 1 switch in this direction. So towards you can see how the screen printed chip is marked. So you want the 1 on this side. Sure that the legs are touching the pads and it's relatively straight, and then it's stuck to the solder pretty well. And that's done. Now the analog to digital converter, it is marked. You can just see that little dot. That dot needs to line up with this U2 mark on the screen print. So you want the dot facing this direction. Just make sure it's reasonably straight, stuck down, the legs are over their pads. Good. When you do this, you won't have to be looking around a camera. That'll make it much easier. All right. So this is the female socket for the ribbon cable. And you can see how it's got a key here that controls which orientation the cable can plug in. And you want that key facing the dip switch. So you want it facing, how do I do this? This direction. So we're gonna put the key facing that way. This one is a little tricky to put down because it sits completely over its footprint. And so when it's down, you can't actually see the pads anymore. So you gotta just make sure that the little wires on the underside are touching the right pads and make sure it's stuck down. That one's also, since it's big, it's the most likely to shift and move in the process of sort of getting this over to where we're gonna do the reflow. Okay, that's it. So at this point, you have done the hard part of surface mount soldering for this. These are stuck down with solder paste. Take a look, make sure things are pointed in the right direction. Again, the capacitors don't matter which direction they're pointed as long as they're aligned with their pads because they're not polarized. The analog to digital converter, this chip here, you want that little dot that you can see pointed in this direction. For this plug, you want the key, which is here, pointed in this direction. And again, you should have as many capacitors in this bank as you intend to have potentiometers in your finished thing. So I've got 3 capacitors down because I'm going to have 3 potentiometers. You might have as many as 8. And then this, the dip switches, should have the first dip switch at this end. As long as you've got that, we're ready to go. So the next step is to actually melt the solder. Here we are in the kitchen. So what we have here is a frying pan on a regular electric stove. And you can use basically any pan that you want for this with a few caveats. One is that it shouldn't be nonstick. You don't want Teflon coating. You can actually see this one looks a little weird because it used to be a Teflon coated pan that I ground the Teflon off of specifically for this. A lot of people use cast iron, steel pan will work. A small steel tray, it doesn't even need to necessarily be a cooking pan because we're not going to get this super hot. But anything you could heat up and which you can have a heat diffuser in. So I'm using sand. This is just sort of clean playground sand as my heat diffuser, and that's a common choice. I think like if you had a thick bottom pan, you'd probably do this directly on the bottom of the pan if it was clean. Sand is nice because it doesn't stick to things and it's good. So this is what I recommend is get a pan that is at end of life, something you're not going to use for food again because you don't want to use it for food after this, and use it for this. So go down to the thrift store, or if you've got like a cast iron pan that's rusting or something, this is good for that. So once you found the pan you're going to use, you do this. I'm doing this on an electric stove. It will work just as well on a gas stove. And in fact, you can do this with a hot air gun as well, and many people do. But I think the stove is it's a little more accessible. So what I'm going to do is I'm going to take the board, which we just prepared with the solder paste. So you can see I was able to move that around and nothing shifted. But do double check that everything's still where it should be. And now that's just in the middle of my pan. Everything's cold at the moment. And I'm going to turn on the heater to a medium high. And then this part takes a bit. You have to watch fairly carefully because the solder paste is sort of a grayish color. So you look at what your solder paste looks like when it's fresh. And then you have to watch it as it heats up, and it will eventually flash silver. And you'll see that it will go from being sort of an opaque gray color probably to shiny silver, and it will also suck onto the metal parts of the components and the pads. And you'll probably see the components shift a little bit when that happens. And once that's happened for every blob of solder on the board, they probably won't all go at once. Then you want to take it off the heat because you don't want to overheat this. But you do need to leave it on long enough that all of the solder does have a chance to melt. So you just sort of have to stand here and watch it. That was instantaneous for you, but about 8 minutes for me. And I can see that the solder has gone silver everywhere, and that the parts have shifted around a little bit. Everything seems aligned with its pads, and it looks like we got pretty good joints. Okay, I'm gonna pull this out. Again, this big part is more likely to shift. Everything else should be pretty well glued down. Just carefully pull this out without disturbing it too much, and set it away from the heat. And then turn off the oven. And then we're done. We have soldered. Here we are back at the bench, and you can see on the camera hopefully that where we used to have, you know, the sort of the paste, now we've got silver joints that are connecting all the components. And everything should look pretty smooth and connected. Glopping the paste on this way, unless you're very, very careful, you'll get slightly uneven. Like some of the joints will be bigger than others. They'll have more solder than others. And that's okay, as long as they're all firmly connected. Like nothing should feel loose when you push it. This one in particular should feel like it's solidly connected. So I think we're good. The next step is to deal with these floating connections where we don't have capacitors in here. So what I'm going to do is I'm going to take this piece of copper wire and I'm going to solder it down by hand over those capacitors. So for that, I'm going to use some wire solder and just a regular soldering iron. And that's what we'll be using for the rest of the soldering in this project. So I'm going to get this straight as I can, measured out to length, so that it sort of lies across all the pads, because these can be shorted to each other or just across the pad. So you could do this with solder bridges if you wanted to, just blob a bunch of solder on, but I like this method better. I'm going to cut that so it's about the right length. Loop a little more solder onto those pads, some of this wire solder. For this, having plenty of solder on makes this a little bit easier. So, and then it's going to go in and lay the wire down and then get it hot. And it will pretty quickly just melt the solder and sort of stick itself in place. And that should be good. I think everything's stuck. There's some little blobs of solder on the surface, but that does not matter. Okay, so now we're going to do, there's this one remaining pad here that also needs to be shorted, and I'm just going to do that with a separate piece of copper. So make sure I got it long enough. So that's soldered down now. This side of the board is done now, and we're going to work on this side. So this part is really, really straightforward. All we have to do is get this Raspberry Pi board connected to these pads. If you intend to attach this to a case or something through these screw holes, it's worth taking a moment here to make sure that they're actually aligned, because you can get this pretty crooked and have it still connected to the right solder pads, but you'll never be able to get the screw through that. So this is the moment to make sure that you can actually fit screws through those holes. I just stick these screws through to act as alignment pins. And there's still a little bit of slop there, but at least you know that that's going to get it close enough that you'll be able to put the screws through. And then I just lay it out and take the iron and just touch it against the pad on the main PCB and then feed some solder in. And usually it will wick into the pad onto the Raspberry Pi. And I do that in a couple of places. Make sure that it does actually. Good. Okay. And so now that board's on there pretty solidly, and get rid of the pins, which are sort of in the way. And then I can orient this sort of however makes sense for working. And then this part's a little bit tedious, but it only takes a minute or two to just go through and get all these glued down. And that's it. So that is the core electronics. This should be ready to go. So next we will do the potentiometers themselves. So we have our electronics ready. And now we're going to make the cable with the potentiometers on it so that we can actually interact with it. So for that, we need our potentiometers, the ribbon cable, bits of wire also in the kit, and the male part of the cable connector. So first off, we need to hook these potentiometers up to power. So The way they're going to be wired is that the outer two connectors go to positive and ground and are shared between all three potentiometers, so they'll be wired together. And then the middle connector goes to one of the wires on the cable, and that's the connector we actually measure from when we use it as a sensor. So what I'm going to do first is I'm going to put a little bit of solder on all of these joints just so they're nice and tinned. Okay, now I'm going to prepare some wire. So I'm going to use this black wire for the ground and the white wire for the positive. And just cut those down a little bit. I need 2 pieces of each. Okay, those are going to be my wires. So now I'm going to strip them in whatever manner you feel. I've got a little wire stripper. I'm going to use that and make these ends relatively long. So those are ready. Now we're going to just put a little hook on the end of each of these so that they can sort of grab onto the loops on the potentiometers. I'm going to go in with the iron and we're going to wire these up. And we're going to do it so as you're sort of looking at the bottom of the potentiometer like this. We want this connector to be ground, this connector to be positive, and then this is the sensor connection. It doesn't actually matter which direction you go, positive or negative on these, because that just determines which direction of turning is up and which direction of turning is down. So if you get it backwards, it might be clockwise, makes it go lower instead of making it go higher. It won't damage the electronics or anything, but I like to get them consistent. So positive, ground. So we'll just do that. So now those are on just mechanically. Next, we're going to solder them down. And these do need to be solid connections because any looseness in these, if they're not completely soldered, will give you noise, especially if you move the device around. So you want to make sure these are good connections. This seems solid. Cool. Okay, so now we've got those ready. We're going to prepare the ribbon cable itself. So let's talk about the ribbon cables. The way I've set up the ribbon cables up, the sensor wires are on this side of the cable where the red mark is, and power is on the other side. So the wires are in order by channel. This is corresponding to the channels that are marked here. So channel 1, channel 2, channel 3, channel 4, etc. Those correspond to the first wire, the second wire, the third wire, starting from the red one and moving inward. And then in those channels will correspond to the CC devices that you'll see in the MIDI messages from the finished thing. And then the last 2 wires at the end are for ground and positive. And the outermost wire, so the very last wire from the red, is ground, and then the one in from that is positive. So what we're going to use for this, since I've got 3 potentiometers, I'm going to use 3 channels, which means I'll use the first 3 wires from this side for those, and then the last 2 for power, and then the wires in the middle will go unused, and I'll just pull those out of the way. So first what I'm going to do is I'm going to take a little knife, and I'm going to very carefully slit the plastic between each of the wires I'm going to be using, so that I can separate them. And if you don't start it this way, there's a risk that you'll tear the insulation down to the actual metal part of the wire, which is no good. So you just do this very carefully and make sure you're cutting only into the webbing between the wires and not into the wire themselves. 2. Okay. So now you can sort of see what I've done. I've separated these out a little bit so that I can work with them. So what I'm going to do is I'm going to grab the wires and just pull gently, and they'll peel back. I'm going to do the same thing on the other side. So now I've got the 2 power wires and the 3 sensor wires that I'm going to use, plus these ones from the middle that I'm going to just fold away so they're out of the way, so that my finished cable is going to look like that. And go ahead and pull these loose a little bit more, like that. And then you need to go in and just get a little bit of the insulation off of the tip here. Very gently push the edge of the blade into the plastic, just a little bit, and then pull. And usually a couple of tries, I can get it to come loose like that. I just do that for all of them. Okay, so now I've got just a little bit of conductor exposed on all the wires that I'm actually going to use. And these I've left completely covered because I don't want any risk of those just touching stuff. Okay, so now what I'm going to do is I'm going to take some solder and just pre-tin each of these tips. And that just helps the little loose wires stick together and make them easier to work with. So just very quickly take my iron, my solder, and just touch it to each of these until they suck up a little bit of solder. And if you didn't get quite enough metal exposed, the heat from the iron will actually melt the insulation back a little bit. You don't want to get it too hot, but that will sort of help enough wire to stick out. Okay, so now let's put the power on. So I'm just going to pick one of these to be the one that I actually connect things to, and I'll just use this one. And so we want, again, the outermost wire on the side away from the red marked wire. So this one, this is ground, and this is positive. There are 2 reference voltages. So we're going to connect this to ground. Feels good. Now we're going to do the other side. So I'm taking the next wire in to be positive. Oh, that one feels pretty good too. Okay, so there's my power. So now I need to hook the sensor wires into the middle 1, 2, 3. And that should be pretty straightforward. Okay. Now you can do sort of whatever you want with this extra wire. I usually just tape it down or cut it back. Here I'm just going to cut it back. Okay. So now we need to put the actual plug on. So the way these plugs work is you can see there's a key, and then up top there's this cap piece with these rather vicious looking little blades sticking out. And so what you do is you slip the ribbon cable between the cap piece and the blades, and then you push down on the cap and it squeezes it all together and sort of locks in place. But you have to make sure that you get the cable point in the right direction. So the way the cable should be is when you're looking at the plug like this with the key facing towards you, you want to take your cable so that the red wire is to the left, so on this side, and you want to slide it through, and it sort of locks in. Like it's hard to get this wrong, so long as you have this pointed in the right direction. So you can see that I've got the red on this side, and then this just needs to stick out just a little bit, and then you want to squeeze, and you have to squeeze quite hard. I find that it actually works best if you sort of push it against the edge of a table, and so I'm going to do that off camera. And there you can see how it's closed down. You can do it with pliers, but you have to be very careful that you don't break the plastic housing. So I like to just get something hard that I can lean on here, and then this up against a table and just push like that. And that gets it pretty good. Sometimes you'll hear a little click when it seats. Sometimes you don't. Doesn't really matter. But it should feel firm. It shouldn't feel loose. You pull on the cable, it should feel real solid in there. And so now we're done. We have our electronics. We have the actual sensors, the potentiometers, and we can connect them together like so. Make sure it's firmly seated. And then you can plug in the USB. Okay, great. Now we can plug this into whatever MIDI over USB device you want to use. In this case, I'm going to use a laptop. You see a green light to indicate power if you have a pre-programmed board. If you're programming your own board, at this point you'll have to flash the firmware. And again, there's instructions on the firmware repo for that. But assuming you have a pre-programmed board, you should see a green light. So now we can go into the MIDI capable program of your choice. In this case, I've got a DAW up, which also happens to be the DAW that I'm recording this audio in. So now I should be able to just assign knobs to whatever software knobs I want. And you can see, so now the hardware knob on the device is connected to the software knob. And I can go ahead and do that for some other randomly chosen knobs. Okay, so there, now we're set up. And again, this should work in any MIDI program that can read CC events, which is anything that has knobs and stuff like this. So there you go. That is a working device, but it's a little bit ungainly. So in the next step, we're going to put together a very simple case. Okay, we have changed craft modes from electronics to papercraft, because what we're going to do next is build the body of the controller. And there's a lot of different ways you can approach this. You can put it in any kind of project enclosure. You can build something elaborate. You can do woodworking, metalworking, whatever. For this, I'm going to do one of the things that I love to do for small projects and prototypes, things that aren't necessarily going to take a lot of abuse, which is use whatever cardboard I have on hand. Any box that I've recently received, just cut it down, glue it back together again in whatever shape you need. And that's great. So in this case, I have a box, actually kind of a nice size for a project enclosure. It's the box that the kit came in. I'm just going to use this, because otherwise it's going to go in the recycling. So we're going to build our little MIDI controller out of this cardboard box. And so I'm going to figure out where I want the knobs to go. I'm just going to take a nice sharp X-Acto and cut a little hole. Okay, good enough. All right. Okay, and then from the underside, I'm just going to poke these through. So note, these have a little tab here, which I'm actually going to cut them off. Grab that thing. Make sure you've got safety glasses on for this, because they have a tendency to shoot. So just grab it as low on the pin as you can, just like get it at the base and squeeze. If you're mounting this into like a metal case where you want to control the alignment, you can drill holes for those pins and use them that way. Okay, stuff each one of these through one of these holes. Alright, and look at it from the other side, and drop a washer and a nut onto each of these. And get these tightened down. And obviously, because we're going into cardboard, you can't tighten them too much. But it is worth noting that if you're on a metal case, you can tighten these a lot, and it is actually possible to damage the potentiometer by over tightening this nut. So, because it'll bend the metal here if you over tighten it. So, don't do that. You know, and on this flimsy cardboard, you don't want to tighten them down too much. So there's that, and then first off, I'm going to figure out where the USB cable is going to come out. I think it makes sense to bring it out the back here. So let's just cut a little slot for that. Doesn't have to be huge, but it needs to be big enough to fit this slim in through with a little bit of persuasion. I'm going to take this and sort of unceremoniously glue it down. you might, like you could put screws through these holes or something, but in this case, let's just tack it down with a little bit of goo. And like that. And that'll hold pretty securely once it's cool. And then get this plugged in. And then we can plug that in, close it up, and it's pretty good. Next up, we're going to prepare the knobs. So if you bought the kit, you'll have a set of these rough oak knobs with the holes drilled, but you have to do the rest of the finishing yourself. So I would just take a piece of sandpaper, this is 120, and just, you know, get the sharp edges off. Sometimes they'll have a little nub in there, and try and get that off as well. There you go. That's totally usable. You can, you know, go as wild as you want with this, and bring it to a finer finish and put a stain on it, and or just leave it as raw wood, because I actually think the raw wood is also very pretty. So quickly do the rest of these. Okay, so there are 3 knobs. Now these will fit pretty firmly onto the shafts of the potentiometers. So when you put these on, you're gonna have to press relatively hard, and you want to do it without damaging whatever you've mounted them into. So this is a relatively soft cardboard, and so I'm gonna have to be careful when I put these on. All right, so there's our basic kit. So this is ready to use. There's one thing we haven't talked about yet, and it's these dip switches. These are used for setting parameters on the board, and with the default firmware, they're used for setting the MIDI channel. In the initial position with all the switches down, the device will use the first channel, and the switches represent a binary number. You can flip the switches to set bits in that number, which means you can change the channel. So if you flip the first switch up, now the device will use the second MIDI channel. And then if you flip only the second one down, the third MIDI channel, etc. And it goes out as a binary number. With that, you can set this to any MIDI channel that you want to use. The device will have to be powered down and powered back up in order for that change to take effect. Thank you for watching. Thank you for building. If you bought the kit, thank you for doing that. I hope it makes wonderful music for you. If you do anything interesting with it or boring stuff, I'd love to see it. Comment here or over on Instagram. And have fun DIY music. Enjoy yourself.